The data here records the number of occurrences of particular types of behaviors in a group of chimpanzees on 23 different days when there are different environmental conditions. And the student wishes to see whether there is any mathematical relationship between the two types of behaviors, behavior 1 and behavior 2. And we can look initially at doing a regression model, stat, regression, fit a regression model, and we will just choose our responses to be the number of B1 behaviors and the predictor as being the number of B2 behaviors. We will go to graphs and we'll use standardized residuals, and we will request a residual versus fits plot. Okay, and then run the analysis. The numerical results of the regression will appear in the session window, where we can see that the best fit linear regression equation is that B1 is equal to minus 10 plus 2.668 times B2. This best fit line has a large negative intercept on the y-axis, which mathematically would require that if there were 0 occurrences of B2, then we'd have a negative number of occurrences for B1, which clearly does not occur in nature. We can look at this just by plotting the XY graph. We go to graph, scatter plot, simple, and we will put B1 as our Y variable and B2 as our X variable and obtain the scatter plot. And we can see on this diagram, origin of the graph, 0, 0 is here. And so we have this large negative intercept if we use a straight line best fit. In addition, we can look at our residuals, and we can see here again this curvature in the residuals, and also the fact that the spread of the residuals appears to increase towards the high end of the fitted value. So we will now investigate whether a transformation would produce a better fit. So we go to stat, regression, fit regression model again, and this time we will go to options and we will choose a Box-Cox transformation, and we request that it chooses an optimal value for lambda. We click OK and we run the analysis again. OK. We can see the residuals fits again, and these now appear to be more evenly spread on either side of the 0 line. So this appears to be a better fit from the point of view of residuals. And then if we look at the numerical results, we see that the Box-Cox transformation has estimated the best fit for lambda as being 0.317, but used a rounded value of lambda of being 0.5. And with the value of 0.5 for lambda, the regression equation becomes B1 to the power of 0.5, which is the square root of B1, is equal to 0.364 plus 0.3463 times B2. So we still have a constant in our equation here, but if we look at the coefficients, we see that the standard error of the constant is 0.441, which is greater than the value itself. So within the margin of error, we could assume that this constant is actually 0. And if this constant is 0, we could just square both sides of this equation so that we would end up with a final equation that B1 was equal to 0.3463 squared, which is approximately 0.12 times B2 squared. So we end up with a squared equation of B1 being approximately proportional to B2 squared.